Tomorrow we're doing a lab on Atwood machines, so you have to be really good at calculations with Atwood machines for tomorrow. Yesterday I did example 1. Tonight I'm going to do examples 2 and 3. Example 2 wants you to do example 1 again, just using these new masses. So mass 1 is 20 kilograms. Mass 2 is 21 kilograms. Since mass 2 is bigger than mass 1, I know that the pulley is going to have mass 2 fall down and mass 1 go up. The heavier one is going to be the one that falls. So the pulley is going to turn clockwise and mass 2 will go down. Just like last night, this problem is about forces and acceleration. Therefore, this is a Newton's second law problem. We will need to know all the forces on both objects, so let's draw free body diagrams. For mass 1, there is its weight, and there is the tension. Since there is only one string, there is only one tension. For object 2, there is its weight, Fg2, and the tension. The tensions are the same for both, and the accelerations are the same for both, because the two objects are connected. Let's get busy with Newton's second law. The net forces on object 1 will equal mass 1 times its acceleration, and since accelerations are the same, I'm not going to differentiate a1, a2, ay, ax. The acceleration is the same for both. Object 1 has a tension on it. That tension is holding it up, and therefore it is positive. It has a weight pulling it down. And let's talk about the sign of acceleration. Object 1 is going to go up based on the reasoning I told you earlier, making the sign of the acceleration for object 1 positive, since up is usually positive y. Therefore, t minus fg1 equals mass 1 times acceleration. Now let's look at object 2. The net forces on object 2 will equal mass 2 times the acceleration of the system, which is the same for both objects. This object, however, will fall down. I showed you earlier mass 2 is heavier, therefore it will go down, therefore its acceleration should have a negative sign. The net forces, or all the forces acting on object 2, are its tension pointed up and its weight pointed down, equals negative m2a, because acceleration is negative. I'm looking for both the acceleration and the tension. I can't solve for both variables all at the same time, so let's eliminate one variable by solving the fnet1 equation for t. I'm going to add fg to both sides, therefore t equals m1a plus fg. Now I'll take that t that I just solved for and substitute it into the other equation. This should be very familiar since we did the same thing last night. Now I have m1a plus fg, and that should be fg1, minus fg2 equals negative m2a. Let's fill in some things that we know. m1a plus fg1 is m1g, minus fg2 is m2g equals negative m2a. I'm solving for a, so I'm going to try to get both a's on the same side. Why don't I take this term and move it over to the left, and then at the same time take these two terms and move them over to the right. Let's save that for the next slide though. Alright, here's where we left off. I was going to solve this equation, m1a plus m1g minus m2g equals m2a for a. In order to get the a by itself, I'm going to take this term, add it to both sides, take these two terms, subtract and add to both sides. And I end up with m1a plus m2a equals negative m1g, it was positive on the left, now it's negative on the right, plus m2g, was negative on the left, now it's positive on the right, because I had to add the positive term, or add the negative term and subtract the positive term. Now I need to solve for a. I'll factor a out of here, and I get a times m1 plus m2 equals negative m1g plus m2g. Therefore, a equals m1g plus m2g divided m1 plus m2 on both sides over m1 plus m2. Substituting in, we can now find the number. A equals mass 1 is 20 kilograms times 10 newtons per kilogram plus m2 is 21 kilograms times 10 newtons per kilogram, sorry about the sloppiness over there, over 20 kilograms plus 21 kilograms. Grab a calculator, I'll do the same. Let's see what we get. So I have, solving this out, 200 newtons for this term plus 210 newtons for this term divided by 41 kilograms. You know what I realized I did? I dropped this negative right here. M1G is negative, so this is negative 200 newtons. So ultimately I have 10 newtons divided by 41 kilograms, and that gives me acceleration equals 0.24 meters per second squared. I found the acceleration. Now the problem also asks me to find tension, so I can sub this acceleration in for the acceleration up here and find the tension. T equals M1A plus FG1. T equals M1A plus M1G. That's the same as FG1. We know M1, we know A and G. T equals 20 kilograms times 0.24 meters per second squared plus 20 kilograms times 10 newtons per kilogram. Grab a calculator. Okay, I get that the first term is about 4.9 newtons. 4.9 newtons. The second is 200 newtons. So my tension then is T equals 204.9 newtons. That is the tension in that rope. Let's talk about why that has to make sense. In order for the block to accelerate upward, tension has to be greater than the force of gravity. The force of gravity on mass 1 would be only 200 newtons. So something greater than 200 newtons, like 204.9 newtons, would cause that block to accelerate up, which is exactly what I told you would happen. Mass 1 would go up, and mass 2 would go down. Moving on to the next example. On to example 3. Two blocks are connected by a string. The system accelerates at a rate of 2 meters per second squared in the clockwise direction. Clockwise direction means that it spins like a clock would, which is this way, meaning that mass 2 moves down and mass 1 moves up. So clockwise is the way a clock moves, kind of like up and to the right. Once again, I'm asked about acceleration, and I can see that there are forces on those blocks. Anytime there's acceleration and forces, F net equals ma will come into play. Let's also list our givens. I've been bad about that on the last two. Acceleration is 2 meters per second squared. Mass 1 is 5 kilograms. Mass 2 is what I'm ultimately trying to find. Let me say right now, it is not immediately apparent to me what I need to do in order to find mass 2. My guess would be that I could find the net force on mass 2 and its acceleration, which I already know. So if I found the net force on mass 2, I could then find its mass. But there are other equations that have mass in them, like the gravity equation. So it's not super clear to me at this moment right here what I will know exactly right before I find the mass. I'm telling you that because I've given you the problem solving strategy of ask what I'll know right before I find the answer. Well, here, I'm not sure what I'll know right before I find the answer. So what I'm going to do is just start trying things. And yes, in physics, if you're not sure how to solve the problem, you should always just start trying things. That's stressful on the actual AP exam because you don't have much time, but real life physics, this is what we do. If a physicist is not sure how to solve a problem, we just start trying stuff. So I know that both of those boxes have forces on them, and in every problem up till now we've used the free body diagrams, so let's talk about them. Mass 1 has its weight on it, and it has a tension. That tension will be the same as the one that's on mass 2, and mass 2 will have its own weight. I also know that this acceleration up here, a equals 2 meters per second squared, is for both blocks. This is a net force problem, so let's look at the net forces on box 1. Net forces on box 1 will equal mass 1 times acceleration. I already happen to know mass 1, so later I can plug that in. The forces on mass 1 are tension pointed upward, so it's positive, and gravity pointing down, so it's negative. Tension minus Fg1 is equal to mass 1 times acceleration. On box 2, I have net forces equal the mass 2 times acceleration. That acceleration, again, will be the same for both boxes, and mass 2 is ultimately what I'm trying to find. The forces on mass 2 are tension pointed upward and its weight pointed down. Those are equal to mass 2 times acceleration. I know that I have to find mass 2. I already know the acceleration. I could find the weight of object 1. So the only thing that I don't know right now is the tension. And once I've found the tension in this equation right here, mass 2 will be the only unknown. What I can do is, just like last time, solve this equation over here for tension and substitute it in to the equation for object 2. So tension equals mass 1 times the acceleration plus the weight of object 1. I just added Fg1 to both sides. Now I can eliminate the variable tension from this other equation by substituting in. So I'm going to substitute what I wrote here into this equation, and for the sake of space, I'm actually going to write it right here. Tension, we now know, is mass 1 times acceleration plus Fg1 minus, just continuing the equation here, Fg1 equals mass 2 times acceleration. Now I can solve this equation for acceleration. Let's clean this up on a new slide and keep going. Alright, here's what I had from the last slide. m1a plus Fg1 minus Fg2 equals m2a. Let's fill in the Fg's with what we really know they are, m's and g's. m1a plus m1g minus m2g equals m2a. I'm looking for m2, so let's get all the m2's on the same side. I'll add m2g to both sides to give me m1a plus m1g equals m2a plus m2g. I'm solving for m2, so I've got to get it by itself still. I'm going to factor out m2, leaving me with m2a plus g. The other side stays the same, m1a plus m1g. Divide by a plus g on both sides, a plus g. Many of you might be tempted to cancel out a and g on the top with a and g on the bottom, but those are added terms. You can't cancel things that are added unless they are exactly the same, and m1a plus m1g is not exactly the same as a plus g. So I'm left with m1a plus m1g over a plus g equals m2. And now if I substitute in my numbers, I should be able to find what I'm looking for. m1 is in this problem it's 5 kilograms. Acceleration is 2 meters per second squared. I'm just looking back up at problem 3 to get these numbers. Plus m1 is 5 kilograms. Gravity on Earth is 10 newtons per kilogram. Divided by A was 2 meters per second squared. Gravity is 10 newtons per kilogram. And newtons per kilogram and meters per second squared are really the same thing, so it's safe to add those. That will give us mass 2. Let's grab a calculator and do these out. 5 kilograms times 2 meters per second squared is 10 newtons. Actually, you may not need a calculator on this one. 5 kilograms times 10 newtons per kilogram would be 50 newtons. 2 meters per second squared plus 12 newtons per kilogram would be 12 meters per second squared, or newtons per kilogram, whatever you prefer. So now, bringing these numbers up here, we have 60 newtons divided by 12 meters per second squared equals m2. Therefore, m2 is 5 kilograms. Now that can't be right. If both masses were 5 kilograms, this system would be in equilibrium. What that means is, when we estimated g with 10, that estimation threw off our answer enough as to not work out. So, go back really quickly, take these 10s, and put in instead 9.81 meters per second squared. When I did that, when I put in 9.81 meters per second squared here and here, I ended up with mass 2 equals 6 kilograms. So let's think about what happened here. I noticed that this answer, m2 equals 5 kilograms, doesn't make sense. So either an error in my calculations, which as I look back through there could be, or this estimation here, because I knew we had estimated that, my brain went, oh, that estimation doesn't work here. My answer, m2 equals 5 kilograms, was unreasonable. So I looked for a reasonable answer. 6 kilograms works. That thing will still accelerate with m2 going down and m1 going up, which means the pulley turns clockwise, which is what the problem told us would happen originally. If they were both 5 kilograms, this thing would be balanced, and it wouldn't rotate. So I found an unreasonable answer, and then started thinking about why it might be unreasonable, what could cause it. It's possible that I did make some kind of math error along the way. I encourage you to go back and look. But I think what happened was this estimation of gravity being about 10 didn't work out. And so I needed to find the exact answer, not the estimation. If you're confused about any of that, watch the video again or call me and we can discuss it. Otherwise, have a good night, and I'll see you tomorrow ready to work on Atwood's machines.